Okay, today we're going to go over 5 through polynomial functions, 5.3, polynomial functions in one variable. So I'm just going to read through the notes and then we're going to look at the examples and probably take a break at that time, then come back and do the second part of the notes. Okay, so reading from the notes, the degree of a polynomial is the largest exponent on the one variable. The leading coefficient is the coefficient of the variable that has the largest degree. A polynomial function is represented by a polynomial equation. It's going to have an equal sign. A quadratic equation is one type of polynomial function. When representing a polynomial function with an equation, put the terms in descending order of exponents on the variable. Values from the domain, the x values, can be substituted into the function to find corresponding values for the range, the y values. F of 3 means find the value of the function when x equals 3. So now we're going to look at these types of polynomial functions. You have a constant degree function where y equals some number, so it's always a constant value, it's a horizontal line. A linear function has a degree of 1 because it's x to the first power. Oh, I'm sorry, this constant function has a degree of 0 because it's a constant term. It's a 2 or a 3, it's a number, it's not a variable. Okay, linear function has a degree of 1 because it's x to the first power. Quadratic function has a degree of 2 because it's x squared. A cubic function has a degree of 3. It's going to be x to the third. A quartic function has a degree of 4. It would be x to the fourth. A quintic function would have a degree of 5. It's x to the fifth. Okay, so let's look at these graphs for just a second and think about what kind of pattern is there for those graphs. Looking at the degrees and looking at the graphs, what do you see that is the same? What pattern is there? Okay, so if you have an odd degree, the ends are going to go in opposite directions. If you have an even degree, the ends go in the same direction. Odd degree, the ends go in the opposite directions. Even degree, they go in the same direction. Odd degree, the ends go in opposite directions. Okay, this one, the first one, has a degree of 0, and it's just a horizontal line. Okay, another thing that you could see is that whenever you have a degree of 2, how many times you have curves, or how many turns you have, is always 1 less than what the degree is. So if you have degree 2, you're only going to have one place where it curves or turns. If you have a degree of 3, you only have 2 places where it's going to curve or turn. Okay, so find the degree and the leading coefficient of each polynomial function in one variable. Explain why, if not possible. Okay, so what you're looking for, first of all, a polynomial, just to kind of refresh your memory, a polynomial is not going to have a variable in the denominator. Okay, so these are not polynomials. Okay, a polynomial will not have a variable in a radical. And if it's a polynomial in one variable, which is what we're going to be working with, it's not going to have like a x times a y. It won't have something like that. It's just going to have one variable all the way through. So as we're looking at this first part, find the degree and the leading coefficient of each polynomial function in one variable. Explain why, if not possible. So first you want to look through the equation or the expression and see if it's a polynomial. So like on the first one, there's no x's in the denominator, there's no x's in radical, there's not an x and a y multiplied together. So this is going to be a polynomial function. The degree is going to be your highest exponent. So let's look at each exponent. The first one is a 4. The second one is a 2. the third one is a 1, and the constant is a 0. Okay, so your degree, excuse me, is going to be 4. And then find the leading coefficient. So the leading coefficient is your constant term that's with the variable that has the highest degree. So in this case, your highest degree is 4. The constant that's with it is 7. That's your leading coefficient. Okay, so let's look at one more. Like on number 3, 7x to the 6th minus 4x to the 3rd plus 1 over x. Well, this one has x in the denominator, so that's not going to be a polynomial function. So that's just like no solution. It's not possible because x is in the denominator, so it's not possible. And I don't have enough space here, but you could write x is in the denominator. Now 4 is different because x is not in the denominator. It's out to the side of the fraction. So you could still do that one. That one's going to be okay. So let's look at the degrees here. X squared, x to the 3rd, x to the 5th. So your degree in this one is 5, and the leading coefficient, the number that's with the variable that has the highest degree, is -1. So that one, they didn't have the degrees in the descending order. So it could have tricked you if you hadn't looked all the way through the problem. You need to make sure and look all the way through. All right, let's look at the next part. If f of r equals 3r squared minus 3r plus 1, find the following. And it gives you different f of a number. So like on number 3, they want you to replace every x in this function, or every r in this case, with a 3. So what that would look like is f of 3 equals 3 times 3 squared minus 3 times 3 plus 1. And then we're just going to simplify that. We're going to do the math and figure out what the answer is. Okay, so this is 3 times 9 minus 9 plus 1. 27 minus 9 plus 1, and I'm getting 19. So that's going to be your value. Okay, let's look at number 9, f of x plus 1. So they're wanting us to put x plus a 1 in for every r. Okay, so that's going to look like this. 3 times x plus 1 squared minus 3 times x plus 1 plus 1. Now when you square a binomial, you have to FOIL it. So I'm going to FOIL the binomial and then put it back into the problem. Okay, so when we FOIL these two together, we're going to get x squared plus x plus x plus 1. So x squared plus 2x plus 1 is what it is simplified. So let's put that back into the problem. F of x plus 1 equals 3 times x squared plus 2x plus 1. And I'm going to distribute this -3, so I have -3x minus 3 plus 1. Whoops. And I'm going to distribute the first 3. 3x squared plus 6x plus 3 minus 3x, and I'm going to combine these last two numbers. -3 plus 1 is -2. Okay, and then finish up combining like terms, so your final answer is 3x squared plus 3x plus 1. Okay, so let's take a break. Go ahead and go get a drink of water or whatever. And we're going to come back in a few minutes and do the rest of this lesson, and then we'll work on it in class on Monday. Make sure and write down questions you have, and we'll talk to you in a second.